In this video, we are going to handle an application of the chain rule. So what is the chain rule? If y is a function of z and z is a function of x, then we can differentiate y in terms of x. And actually we can have dy over dx is equal to dy over dg times dg over dx. So if you're not familiar with the Leibniz notation, then we can also express it as a Newton's notation. So if y is fz and z is equal to zx, then dy over dz is equal to f prime z, and dg over dx is equal to z prime x. So dy over dg part is just f prime z or f prime gx, and dg over dx is g prime x. So we can have this equality. So how do we apply the chain rule to a problem? So here is a problem. Look at the figure. The metal bar of a length L in the figure below has one end attached at the point P to a circle of radius A, and point Q at the other end can slide back and forth along the x-axis. And then this point is rotating like this, counterclockwise. So assume that the lengths are in centimeters, and the angular speed d theta over dt is 2 radians per second counterclockwise. So we are looking for the speed at which the point Q is moving when theta is equal to pi over 2. So we want to know dx over dt. But from the figure or from the problem, we probably cannot express x as a function of t. But we can recognize that x is a function of t. Well, actually, we can express x as a function of theta by looking at the figure. So you may differentiate x in terms of a theta. So x is a kind of function of a theta, and we know that the theta over also dt, because this is given in here. So by the chain rule, we can have dx over dt is equal to dx over d theta and times d theta over and dt. And this one is already given in here, you can see. So if you can express x as a function of theta, then we are done by plugging pi over 2 into theta there. So how can we express x as a function of theta here? We need to have some idea. So if you have this, then you can consider right angle and right triangle in here, okay? Then we can determine this. This is a cosine theta in here. And similarly, this is a sine theta in here. This is also right triangle. Okay, so we can determine this one by using the Pythagorean theorem. So this part is equal to square root an L squared minus a squared sine squared theta. So we can express x as a function of theta. So which is equal to a cosine theta plus square root L squared minus a squared sine squared theta here. Okay, so now we can determine the derivative of x in terms of theta. So x is equal to a cosine theta plus square root L squared minus a squared sine squared theta. So if you differentiate in terms of theta, then differentiate cosine theta, then we know that that's minus sine theta. And if you differentiate this one, you can apply the chain rule again. So this is 1 over 2 L squared minus a squared sine squared theta. Then we need to subtract 1 in here. So negative 1 over 2. And then you want to differentiate this one also. So that is minus a squared. And also you can apply the chain rule again. Then you have 2 sine theta. And then you want to differentiate sine theta again. So you will have cosine theta and here. So this is equal to minus a sine theta. And 2 cancels in here. So we have a minus a square sine theta cosine theta. And then we have this part. So which is equal to square root 2 L squared minus a squared sine squared theta in here. Actually, we want to determine dx over dt when theta is equal to pi over 2. So by applying the chain rule, so dx over d theta in here, when theta is equal to pi over 2, and this is d theta over dt, but d theta over dt is already given, which is equal to just 2 in here. Now, if you plug pi over 2 into theta in here, then what will you get? This part is minus a sine pi over 2, which is equal to 1. And if you plug pi over 2 into theta, I mean here, cosine pi over 2, we know that that's just a 0. So this part is just gone in here. So this is minus 0 here. But don't forget this part, so this is equal to 2. So you will have minus 2a. But this is a centimeter and per second. So with the different values of theta, so for example, theta is equal to pi over 4 or pi over 3, still you can apply the chain rule. Thank you for watching.